Welcome back to Think Thrice Problem Solving. Today we're going to be solving a fun little geometry problem. So we have a circle, and inscribed in this circle is a square, a blue square, and that blue square intersects our circle at the four corners. So it's perfectly inscribed in there. And then on the side here we have a circle that shares a side with the square, and then it intersects our circle at the opposite two corners. So technically there's a little gap right here between the side of our square and the circle. It's just really small, it's hard to see down there. Okay, so what do we want to do? We want to find the proportion of the area of the red divided by the area of the blue square. So if you want to give this a shot, go ahead and pause the video. Otherwise, we're going to jump straight into a solution. So what we're going to do is we're going to look at a few different things, but we're going to start off by drawing some lines in here. So I'm going to draw this line. I'm also going to draw this little line down here. So I just drew a line right there. And I'm going to draw another line that goes down here to this corner. So this green line is the radius. But another way to draw the radius is this line right here. So I'm going to define a few things. So one, I'm going to define the side of my square as A and the side of my red square as B. So what I'm trying to do essentially with my problem up here is I'm trying to find B squared divided by A squared. So this is essentially what I'm trying to do. So it'd really be nice if I knew what B over A was, because then I can just square that proportion. Okay, so what I'm going to do now is I'm going to look down here, and I see if I draw this right angle down here, this is going to be A over 2, and this is going to be A over 2. And I can actually solve for R. So if I look at this triangle and do Pythagorean theorem, I can see that R squared is going to be equal to A over 2 squared plus A over 2 squared. So R squared is going to be 2A squared over 4, which is going to be A squared over 2. And that tells me that R is going to be A over the square root of 2. Okay. So I have my radius. That's going to be very useful going forward. Now let's take a look at a different triangle. So let's take a look at this triangle here, which also is a right triangle. So if we look at that right triangle, I can then solve for a few things. So let's look at my blue side here. What is this blue side? So this blue side is A over 2 plus that side B. So I'm going to write that as A over 2 plus B. And we're going to use Pythagorean theorem, so I'm going to square that. Then I'm going to square this small side, so B over 2, square that, and that's all going to be equal to R squared. And R is this A over square root of 2, so that's going to be A over square root of 2 squared. So let's go ahead and write this out. So I'm going to get A squared over 4 plus 2 times AB plus B squared plus B squared over 4 is equal to A squared over 2. So what I'm going to do now is I'm going to write everything on one side of my equation. So A squared minus A squared over 4. So I'm going to have 0 eventually. I'm going to have A squared over 2 minus A squared over 4 is going to give me A squared over 4. I then have 2 AB, oh, this is 2AB over 2. So I'm going to take this guy, and that's kind of by itself. So I'm going to have minus AB. And then I have these two guys. I'm going to combine. So B squared plus B squared over 4 is 5B squared over 4. So it's going to be minus 5B squared over 4. Okay, so what I'm going to do now, this is kind of the tricky part. So I notice up here that I'm looking for B over A. So let's kind of artificially put a B over A into our equation. So coming down here, I'm going to take 0. I'm not going to change this first term. I'm going to leave it as A squared over 4. But then I'm going to write this as A And now I want b over a. So if I divide by a here, I also have to multiply by a. So a squared b over a is the same as ab. But now I have that a over b term. And I'm also going to do that over here, except now I'm going to have 5 over 4. I'm going to have a squared times b squared over a squared. Okay, you see what I did there? So I multiplied and divided by a squared. And what that's going to do is that's going to give me this b over a in my equation where it wasn't there before. And I also notice that all of these guys now have this a squared term. So what I'm going to do is I'm going to pull out that a squared over 4. And what that's going to give me is 1 minus 4 times b over a minus 5 times b over a squared. Okay. So what do we know? So from this equation, I know one of two things must be true. Either this guy is equal to 0, or this guy is equal to 0. And I know that this does not equal 0 because a is the length of my side of my blue square, which is, given the problem constraints, not 0. So that means that this whole thing on the right must equal 0 in order for my whole equation to equal 0. So I'm going to do a little substitution, and I'm going to make y equal to b over a. And then I'm going to rewrite that portion of the equation as 1 minus 4y minus 5y squared is equal to 0. And then I can just use the Pythagorean theorem. So I get y is equal to 4 plus or minus the square root of 16 plus 20 divided by 2a, and a is negative, so this is going to be divided by negative 10, which gives me 4 plus or minus the square root of 36, which is 6, divided by negative 10. So I know that my side length must be greater than 0. So if I did 4 plus 6 divided by negative 10, that would give me negative 1, which is no good. So I know I need to use this negative term. And what that's going to do is that's going to give me 4 minus 6 over negative 10. So y is going to be equal to positive 1 over 5, because it's negative 2 over negative 10. Okay, and what was that y? So that y value was my b over a. So I've just solved for b over a. So what do we note here? What we're trying to find is the red over blue, which is b squared over a squared. So what we've just found is that red over blue is going to be equal to b over a squared, which is 1 over 5 squared, which is exactly 1 over 25. So the proportional area is going to be 1 over 25. And that is going to be our final solution. So I hope you enjoyed working through this problem with me. If you did, please like and subscribe. If you have your own problems ideas, please submit them to thinkthriceproblemsolving@gmail.com. And as you're working through problems on your own, think once, think twice, and if you ever get stuck, think thrice.